With Gordon Hanson, Lin Tian, she just graduated from Columbia. She's going to INSEAD, and John Boyle. So this paper is about trying to study the impact on American workers of an inflow of immigrants in the labor market. Obviously, there's a lot of work in this area. And most of this work is comparing outcomes across, say, regions that are differentially exposed to immigrants. So, for example, the typical episode is the inflow of Cubans into Miami, and people use that in the 80s, and people compare the outcomes, employment wages, etc., between Miami and, say, Cincinnati, that receive fewer immigrants. And also, there's a lot of work comparing outcomes between broad education groups. So, what happened to unskilled immigrants, unskilled native workers versus high-skilled native workers. And this is a very active and very contested research area. So, and it makes sense because it's very hard to think about, I mean, what causes the inflow of immigrants into a region.
There's somebody presenting at the SCD meeting in Edinburgh, and what he was doing was really relevant to this Borjas versus anti-Borjas. I said, what's your point of view on this? He said, I'm coming up for tenure soon. I had no point of view.
That's John Boyle. I was there.
Oh, you were there? Yeah. He said,
Gordon Hanson.
This is so contested.
Gordon, he calls it as it's a radioactive literature. You don't want to get close to it.
Insulting each other.
Yeah.
About what happens to wages?
Yeah. Or employment. Or.
And who are the two sides?
Borjas, Card, Perry. There's.
What about the guy who was?
Borjas claims.
Who's the guy from MIT? The labor guy that you're
Autor, David Autor.
He has all these.
Yeah, but not on immigration. I think it's not in. Yeah.
No,
that's trade.
Yeah. Okay. So what we want to do is we want to study the impact of immigration.
I thought you were there at that.
Yeah, I was there. Yeah. We want to think about within regions, outcomes across different jobs, occupations that are differentially exposed to immigrants. So, for example, think about housekeeping, which is very immigrant intensive in many regions in the US, versus firefighters. We want to understand when immigrants come to town, what happens to native workers that start in this occupation versus this occupation. And second, we want to think about what's the role of tradability. Does it matter whether the occupation or industry is tradable or not for how immigrants shape the response of wages and employment? So what we do is we do three things in the paper. First, I mean, it's the second part of the paper, but let me describe it this way. We're going to document what happened across jobs within regions when immigrants come in. So basically we want to understand, do immigrant workers displace native workers away from occupations which are immigrant intensive? We call that crowding out. Or do native workers move into occupations which use immigrants intensively? We call that crowding in. And what we're going to document is that immigrants tend to crowd out workers, native workers, away from immigrant-intensive occupations within the set of non-traded occupations, and I'm going to define those in a little bit, whereas within the set of tradable occupations, we don't find neither crowding in or crowding out. So the adjustment is very different in terms of crowding in, crowding out within the set of non-tradables versus the set of tradables. Second, we're going to think using a model why. First, should we expect there to be crowding in or crowding out? And second, why should there be a differential adjustment comparing tradable and non-tradables? And basically, the mechanism is very simple. Fixing the price of the industries or occupations, the model is going to predict that there should be crowding in. So native workers should move into industries that are intensive in immigrants. Why is that? So think about fixing the price of, say, if I produce furniture, which is a very tradable industry, and labor increases, one of the factors that I use increases, the supply, the wages are going to go down, and I'm going to expand. Okay? And so native workers are going to move to those occupations. That's at fixed prices, and that's exactly the Rybczynski result in trade. At fixed prices, industries that use a factor intensively should expand disproportionately. However, as the supply goes up, the price is going to fall. If the price falls sufficiently, there's going to be crowding out. In occupations in which the price falls more when the supply goes up, there's going to be more crowding out. And those are going to be the non-traded occupations. I'm going to show you that mechanism in a couple of slides. And the third thing we do is we want to think about what that implies for wages. And the model is going to imply that if there's crowding out, if native workers move away from an occupation into another occupation, then the wage of workers that start in the occupation that is crowding out, the wages are going to fall in those occupations relative to the other. So this crowding out is going to induce changes in wages across occupations within regions. In particular, workers in immigrant-intensive non-traded occupations are going to gain less or lose when there's an inflow of immigrants. So
do you trace where they go and then check that out? The guys who get pushed out, you check where they go and say what happens to them at the end?
what happens to the wages?
Whatever, yeah.
We don't follow the same guy over time because we're using census data. So we look at like shares. It's all going to be about shares. All right. So I'm going to first start with illustrating
the total effect. What happens to people? Do they get screwed at the end? Don't you have to kind of trace them down? What happens to them?
What happens to their
Displaced Americans.
I mean, so that would be the ideal thing. We do something on. No, not in this data.
Can't you with PSID?
Uh,
Be big enough.
yeah, probably.
Peanuts.
Yeah.
Okay.
So I'm going to first kind of give you like a simple model to show you why there could be crowding in or crowding out and why there's relatively more crowding out in non-tradable occupations. Then I'm going to use the model also to guide the regression we're going to run in the data to document this. Then we're going to write finally like a bigger quantitative model with other features that are not in the simple model. We're going to calibrate it using these regressions. And we're going to do some counterfactuals to look at the implications on wages within regions. That's the focus of the paper. But the model is also have something to say about what happened to wages between regions, kind of closer to what people have done before. Okay, so the model kind of, given that it's a short talk, I'm going to give you like the three key ingredients and the main comparative static. So the one ingredient is, so there's going to be many regions in the. It's a closed economy. We don't think about the rest of the world. We're going to think about local shocks in LA versus Miami, for example. So we're not going to think about the rest of the world. So every region is in the data is going to be a commuting zone in the United States. So there's 722 R's. So this is output in region R of a given occupation. Let's say textile operating occupation. Okay, and there's going to be 50 in the data. And it's going to be produced using two inputs, labor, immigrants, and labor domestic. And these L's are inefficiency units. Okay? So there's going to be some productivity of the occupation in the region. This could also be, you can add some other input like capital or land, as long as there's concern to scale. That's going to be like, you can think of that in A. And then these two parameters are going to be productivities of immigrants and domestic workers in a given occupation, and they're going to basically determine the immigration intensity of an occupation. So if suppose that rho is bigger than 1, if immigrants are relatively more productive than domestic in O relative to O prime, then occupation O is going to be immigrant intensive in the sense that it has a higher share of immigrants in labor costs. Okay? A normalization of what? So, I mean, it's. I mean, the ratios will only the relative. It's comparative advantage, so it's always relative relatives. Yes.
Yeah.
Yes.
All right.
Now.
So, but just 1 second. I mean, that's fine. I know what you're trying to get out of this, and that's fine. But I'm nervous about it with the housekeeper versus firefighter. Because
You mean that
it's a restriction. No, it's a restriction. It's a government imposed restriction, not an efficiency thing. I bet a foreigner could be an immigrant could be a good firefighter, they just don't hire them.
Yeah, probably you can put it some wedge instead of productivity. It's going to imply the given shares.
Yeah, but then for
we're not going to
welfare and stuff.
Yeah, sure, but we're not going to. Yeah, but we're not going to be looking at efficiency or.
Okay, fine.
Yeah, I mean, and the other thing is, so rho is rho is going to be an important parameter. You can think rho is equal to infinity. That's the case for the perfect substitutes. We're going to nest that, but in the end, we're going to have rho equal to 6 to match our regression. So it's pretty high, but it's not infinity. You might still not like that the passport matters for the production in the production function. I don't like it either. So we have like your passport, where you were born matters.
Passport.
Yeah, your passport, citizenship. Yeah. So one way.
Because the guy's an immigrant, has a green card. 5 years goes by, he shows up in thing, swears, and then jumps from one category to another.
Right. So one way to think about this, which gives exactly rise to this production function, is one where each occupation is produced using a continuum of tasks. So think writing a paper requires proving theorems, writing MATLAB codes, and writing an introduction. Within each task, I am perfect substitute with John. Okay, but we have different skills. So I'm relatively better at writing MATLAB codes. He's relatively better at writing. So then that's going to give rise exactly to this production function where rho is going to be basically associated to the comparative advantage across tasks within an occupation. So that's exactly the same algebra. All right, so this will be for now, let's think about a fixed number an exogenous number of domestic and immigrant workers in a region.
For certain parameters, if you set the immigrant person to 0, the whole production is 0, right? Because it's like
so
your story went to 0.
Yeah, so we need it to be rho bigger than 1. In that story, you need rho bigger than 1.
Okay.
Yes, that's true. So so the second ingredient is this one. So the supply of workers. So think about for now we're going to take the number of workers. This is in numbers. This is in efficiency units, but as given in a region, domestic workers and immigrant workers, they're exogenously given. In the full model, we're going to have endogenous mobility, but not for now, across regions. Now, each worker, each domestic and immigrant worker, is going to draw a talent or a skill to work in the different occupations. So they're going to draw a vector of epsilons. So this is Z, this is Joe Smith. He gets an epsilon associated to each occupation, so 50 numbers. And he's going to choose the occupation that gives him the highest labor payments, where the labor payments are equal to your skill times the efficiency wage. We call that occupation wage, which is I or D specific. K could be the D or I, all right? So the efficiency units in occupation O is just the integral of all the epsilons employed in this occupation. Okay, so why do we have that? Why do we have this feature? Why do we have this variation in epsilons? We want to think about the impact on relative wages across occupations. If epsilons are the same across occupations, then relative wages are going to be fixed across occupations. So whereas if we have variation in epsilons for a given guy, in order to induce workers to switch into another occupation, the wage is going to go up in that occupation. Okay, so that's that's what this rho occupation choice model implies, and we're going to parameterize that dispersion with a parameter theta in a Frechet distribution. So epsilon is going to be drawn from a Frechet distribution. The bigger is the dispersion of the higher is theta, the lower is the dispersion of epsilons, and the higher is the labor supply elasticity. In the extreme, when theta is infinity, there's no dispersion in wages across occupations. Okay, so that's the only role of this parameter is going to be to determine how relative wages move between occupations. And the third ingredient is where the tradability matters. Okay, so basically let me say something worse before talking about the algebra. So the tradability is going to affect the price sensitivity of an occupation to changes in output in that occupation. So in the extreme, tradable occupations are going to have the price is going to be given, whereas for non-traded goods, the price is going to fall when output goes up. Okay, so that's the only role of tradability here, the price sensitivity of an occupation. How do we model that? That difference in the sensitivity of prices? We're going to do this as follows. So in each region, R, there's a final good that combines consumption or absorption across all occupations. This is a CS aggregator, where eta is the substitution elasticity between goods or between occupations. Think of that as a low number. And then each occupation, absorption of each occupation, is another Armington aggregator across different source regions with an elasticity alpha. So you're going to consume, say, furniture, and you're going to be using a bit of furniture from every location. It's like the simplest way of thinking about trade. This model. So that's going to be alpha. Think of that as a high number. It's like 6 or 7. This is a number like 2. There's trade. So output of an occupation in a region has to be equal to absorption in other regions times the trade cost. And the trade cost is going to be higher for non-traded occupations than for traded occupations. What matters in the end, as I said before, is that the occupation demand elasticity, epsilon rho, which is if you change if the price of the occupation falls, how much as demand for the occupation in this region goes up, that's a weighted average of these two parameters, where the weights are determined by the trade shares. If there's no trade for this occupation, this region, so if S is 0, so this is 0, this is 1, then the effective elasticity is eta, it's a low number. If trade is higher, if the trade shares are higher, then you put more weight to alpha, so that's a bigger number. In the extreme, Rybczynski say, alpha is infinity, so you take the prices as given, so the demand elasticity is infinity. Okay, so that's the only difference here between tradable and non-tradable occupations. The price responds to an increase in demand.
But, so let me just think, I mean, no, this is good, but I don't understand how alpha can be high without having a high trade share. It's if there's a big trade barrier, if it's because tau's high. See what I'm saying? It seems like if alpha.
I mean, I'm thinking that in general, in terms of technologies, gardening and firefighters are less substitutable than gardeners, gardening services in LA and gardening services in Minneapolis.
I think he's asking a different question. Can't in the top one, the mu control the trade share indirectly?
Oh, it does.
No, because this is occupation specific. These are trade shares within the occupation. It's like how much you buy from your region within an occupation, and how much.
It looks like you're missing like a CES weight or something then.
Yeah.
Oh, here we go. Yeah,
Do what Tim said.
sure.
Yeah.
We know. I
If
mean,
you need a CES weight, then you can
Yeah,
trade
here.
low or high by the extra weight.
No, put
yeah,
it
sure.
inside.
You can do it with trade costs. Yeah,
It
sure.
could be
Inside.
trade cost.
Yeah, but
It's like
it's the same.
The mu up there, down there.
Yeah.
With the alphas.
Yeah, it's the same. They play the same role.
Yeah.
Yeah.
Totally.
So,
Oh, he said trade costs. Okay.
so an occupation is a good in this model?
In that, yes, but in the data we're going to do everything either for occupations or for industries. We do them separately because we don't have enough data to do
So like
the
thinking
two.
about, because you keep using stuff like a gardener. That's good. That is like an occupation sort of.
Yeah.
Like an accountant can work for.
I mean, these are the occupations. Let me, so you can fix it. These are going to be some of the. We have 50 occupations.
Yeah.
These are going to be like the least traded. Of course, there's no trading guards, right? You need a guy to be there.
Yeah.
And that's why we do it for occupations, because you could have like a manufacturing firm and a plant that is clearly traded, but then some occupations are clearly not traded.
Yeah.
Right?
So the manufacturing firm goes away, the guard, my demand falls, right?
Right. So that,
guarding non-tradable businesses. I just want to. So in the data that you're going to think about these two things as being separate and kind of interacting with each other.
what? So what two things to be separate?
Jobs and goods.
So we're going to have an occupation,
Yeah.
say teachers, that use some immigrants and some native workers. The only question is the price of teaching services determined by demand conditions in LA, or are they determined by demand conditions in the whole country? So what we're going to have is that for non-traded goods, the demand for LA is more important.
In other words, Kim, I think he's trying to say, he's going to sometimes call them like industries, and sometimes they're jobs.
Yeah, but I would like, I mean,
Okay, no, I was just trying
No,
to,
but
I was trying to figure out an important sort of bit here is that my occupation I can use in different industries. Or
Right.
I should be thinking about an occupation sort of being an industry.
again, in the data, we do the two separately. One thing we do is at some point we remove manufacturing, which is only like 20% of employment. So there, we're looking at mostly non-traded goods,
Yeah.
at least internationally, and the empirical results are similar. Okay. Okay. So now that so those are three ingredients. Okay. So the production function with an elasticity of substitution between immigrants and native workers, and comparative advantage that determines the shares. A labor supply in each occupation, so that we have different occupation wages across occupations, and the demand sensitivity of occupations being higher for tradable than for non-tradable. So now this is the key comparative static from the model. So suppose that the number of immigrants in Los Angeles rises. Okay? So now, how can you clear the labor market? There's no unemployment here. So you need to reshuffle workers in a way to satisfy labor market clearing. There's two ways of doing it. One is simply to expand occupations that use a lot of immigrants. Okay? You can keep the labor ratio of immigrants to natives fixed in each occupation, but expand disproportionately the ones that are immigrant intensive. And that's going to generate crowding in, right? Because you need to move a lot of workers towards those occupations that are immigrant intensive. And this force is going to be stronger the more sensitive is occupation demand to price. That's the case where these occupations are going to expand by more. And that's exactly the Rybczynski result for anybody of you that took an undergraduate trade class. That's at fixed prices, so demand is very sensitive to prices. That's why prices are fixed. Rybczynski is exactly designed to answer this question, but it's a very strong assumption and it implies crowding in. Now, the other way of clearing the market is don't reshuffle output across occupations, just make every occupation more immigrant intensive, okay? And that force is going to generate crowding out, because if you make occupations very immigrant intensive, all occupations very immigrant intensive, you have to move workers away from occupations that are immigrant intensive. And this force is going to be stronger the more substitutable are native and immigrants. Okay, so depending on the relative force of these two margins, you're going to get crowding in or crowding out. Okay, in the end, let me put this in a compact way. So this is the main result of the paper, theoretical result. So these are all lowercase letters are log changes over time in response to a shock. So again, the shock is here, an increase in the number of immigrants in the region. That's here. That's a percentage change in the number of immigrants in region R. Okay, and this basically says what's the change in employment of either immigrants or domestic workers in occupation O versus O prime. And under some assumptions, like we take prices and quantities in the other regions as given. Okay, what we're going to get is that this is equal to the shock times the difference in the immigrant intensity times a parameter, beta. Okay? If beta is negative, that's a case where there's crowding out, where employment falls in the immigrant intensive occupation compared to the non-immigrant intensive occupation. And if beta is positive, there's crowding in. And what we show is that there's crowding out, beta is negative, if and only if the elasticity substitution between native and immigrant workers is higher than the price sensitivity of demand, epsilon. That's exactly the case where 2 is stronger than 1. Okay? So if immigrant and native workers are very substitutable, there's going to be crowding out. In the extreme, if you think that they're perfect substitutes, then there's always going to be crowding out. On the other hand, in the Rybczynski case, epsilon is infinity, so there's always crowding in.
Which was epsilon? I thought
That's the price sensitivity of demand. If prices are fixed, if you take...
Sorry, can you go to your equation? I thought that was the...
That's this. It's how much does demand fall when you increase the price.
Because I was expecting to see alpha, but see, it's in the epsilon.
Right. So that's the main result. So the model can generate crowding in or crowding out depending on the comparison of these two parameters.
One more that I think again. productivity was a weighted average of the inside
Right.
and the outside.
Right.
That's like that formula, right?
It is.
That
Yeah, but it's for very different reasons.
was a nested CES gave you that, or am I
Yeah.
mixed up?
Yeah.
Didn't you have something like it's always a weighted average?
No, I guess it's the same. It's the same. Yeah, it's the same logic. It's the same logic. It's the same logic. Yeah, it's the same logic. It's the same logic. Yeah, that's true.
But the second thing, you stick it in the first thing, that's the CES.
Yeah.
Yeah.
No, you're right. It's exactly the same logic.
Okay.
Yeah. So, all right. So we can get crowding in or crowding out depending on this.
And that beta RK has the equal. You're holding fixed outside, but in your thing you're letting
Price.
it
Yeah. Yes.
So
Yes.
that is the full equilibrium that beta has been
Within the region.
Within the region.
Yes. Yes. Exactly. So now this depends on G. So this will be different for tradable occupations than for non-tradable occupations. That's coming next. For wages, it comes directly from what happens to relative employments. If there's crowding in, so if employment goes up in O versus O prime, so if native workers move from teachers to gardeners, that's crowding in, then the wage of gardeners has to rise relative to the wage of teachers, except for the case where theta is equal to infinity. Crowding in is when immigrants, Mexicans come in, there's the share of Americans that are gardeners rises relative to the share of Americans that are teachers.
Because gardening has become so much more important as an industry.
Right.
And the Americans are
The teacher garden. Wait, here's what confused me with that. Sorry.
Teachers are maybe not, they're very non-immigrant intensive. Firefighters and teachers are not very immigrant
Say
intensive.
crowding in again with the abstract words then.
Crowding in is basically when immigrants, the number of immigrants comes in, so this is positive, and this is bigger than this, so O is immigrant intensive compared to O prime. Employment in O of natives rises relative to employment of O prime.
In immigrant intensive ones, if it goes up, that's crowding in.
Yes. That is, if natives move towards jobs, occupations that are very immigrant intensive.
Go back to your CES thing. I'm just.
Which one?
Make sure. The top one. No, right there.
This one.
Pat, all kinds of LI guys are coming in. If that industry expands like crazy, it's going to make sense. You're going to hire some
I see.
domestic guys. So you actually even hire more domestic guys.
Right.
That's to do
But
with
that's
the-
because they have this funny assumption that the Mexican gardener,
I see.
every 5 Mexican gardeners needs an American guy to
Yeah.
come along with them to help them do the
Is the
project.
marginal
I mean, it's
product-
raw. I mean, I'm not assuming rho equals 0, but
Right.
it's not. It's not.
This is
If
like-
rho is equal to infinity, then there's always crowding out.
Right.
So the simple idea is the marginal product of the natives goes up when you have more immigrants because
Right.
of the cross partial.
Right.
Right.
But then,
And that's one effect.
yeah, the other one is that the price falls.
The other is the price fall.
Right. If the price falls
I see.
sufficiently, you want to move them
I
away.
see.
Exactly.
So the marginal product, cross marginal product is big. When you hire immigrants, you need the Americans to go with them.
Exactly.
The delta would be the extreme.
Like- Yes.
And when there are more substitutes, you have a lot more immigrants. What does it do? It drives
When
down the price. If it's a non-traded good, it drives down the price.
more than if it's tradable.
You have more substitutes,
Yeah.
no matter whether it's traded or not. You're not going to get the
Okay.
crowding in.
Got it.
Crowding in,
Got
you
it.
need low elasticity
Yeah, yeah.
and the price not changing.
Take too long to if it's the extreme. Then
Right.
it's always going. Okay.
Right. And then what happens to wages?
Need an American.
And what happens to wages follows directly
Okay.
from the occupation. If you want to induce Americans to move to gardeners, you have to increase the wage of gardeners versus firefighters or teachers. So adjusting by the labor supply elasticity. And the last point is, what about T versus N? That's the main focus of the paper. Given the assumptions I made, the price sensitivity is lower for N than T. So this force is going to be stronger for this force is going to be stronger for tradables than for non-tradables. So the model implies that there's more crowding out comparing non-tradable jobs than comparing tradable jobs, and the wages fall by more in immigrant-intensive occupations within N than within T.
So you probably said this already, but you assume that rho is the same for all occupations?
Yes, that's in our baseline. So I'll come back to that.
Different rows.
We did one thing to that. I'll come back to that. I mean, you could think. I mean, another way of getting our empirical result is that within tradables there's a less substitution between immigrants and natives than within non-tradables. So the other way, within non-tradables there's more substitution. That could also generate our empirical facts, but not for something else on labor payments that I'm going to show. It's going to have counterfactual implications for one of our results. Okay, so now we're going to document what actually happened in the US within regions. Did we see crowding in or crowding out? Is it different within N than within T? And we're going to start, to tell you the regression we run, we're going to start from this equation. Okay, I'm going to rewrite it in a way that is identical, which is like this. So that's exactly the same equation. So now this is a fixed effect that is region group specific, so T or N. Remember, I had the difference between two occupations. I can move one of the occupations to the right, and that's going to be in the fixed effect. And then this X is what I had in the formula. It's the shock, the region shock, times the immigrant intensity. I'm going to call that X. And then there's a different beta for non-traded occupations. That's an indicator for non-traded occupations than for traded occupations. So that equation is exactly the one implied by the model, where this allows for changes in productivity or demand for the occupations. Okay.
This is all normalized relative to base occupations?
We're comparing always outcomes within tradables or within non-tradables. I'm not going to say anything about what happens to the size of tradables versus the size of non-tradables. Okay. It's like, do we see movements into or out from immigrant occupations? So the model implies that beta n, the only robust implication of the model is that beta n is negative. That beta should be lower for non-traded occupations than for traded occupations. Okay? But beta could be positive or negative. We're going to estimate an expanded version of this, which at this point is going to be reduced form, in the sense that we're going to add a bunch of things. Then in the full model, we're going to add these things too, and we're going to run the same regression. So one thing we're going to add is occupation fixed effects, which we didn't have in the model. In the model, this is fine, but we want to allow for other reasons why demand for occupations changes over time. So that's going to be these occupation fixed effects. Second thing is that in the model so far, it didn't distinguish workers by education. In the full model, we will. But for now, we're going to run this regression for each education group, high skill and low skill separately. Okay? And third, rather than bunching all immigrants together, we're going to also add them separately by education. So this X is going to be the sum of this by education. Again, you didn't see this in the model because we didn't have this. We will have it in the full model. And the third thing is that we're going to estimate the average beta across regions rather than region by region. All right? So that's what we're going to run. There's one more issue, which is that the number, this NRI, the number of immigrants entering LA could be endogenously responding to some demand or technology shock for an occupation. So the number of Indians into Palo Alto may be rising because of an increase in high tech in Palo Alto, okay, or in San Jose. So we need to worry about that.
No, at Palo Alto, the number of Indians
or San Jose.
Up because like the greatest economist in the world is an Indian economist, and Pat's boss.
Yeah, so actually Palo Alto is not even in our. Yeah, so we're going to. It's not such a big deal for us because we have a region group fixed effect, but we're still going to instrument, and the results don't matter much. They're very similar, OLS or instrumented. The way we're going to instrument is rather than using the actual number of immigrants immigrants into San Jose in these two time periods, we're going to use the total number of immigrants into the United States, except for San Jose, between these two time periods. And we're going to allocate them across regions according to where the Indians or where each country of origin were allocated in the initial year. That's called the card instrument. People use it a lot in this literature. Okay? So in that sense, we're not using the actual number, but a predicted number of immigrants using information that is not in San Jose. Okay? There's still some assumptions we have to make for this to be well identified, but Given the lack of time, let me show you the regressions. So we use data from 1980 to 2012. We're going to do things by decade as well. This is a period where the number of immigrants in the US, the share went from 6.6 to 16.4, so there's a big increase. Again, the regions are going to be the Otterdoorn-Hanson commuting zones. We're going to have 2 native groups, some college or less and college or plus. We're going to have 3 education groups for immigrants. And when we do the instrumental variable, we're going to use 12 countries of origins or source countries. For occupations, we're going to use 50. It's an aggregation of the 64 headlines of the occupations in the census. Tradability. So we're going to do 2 things. Again, none of these measures is perfect. So one is for occupations, we're going to use the Blinder and Kruger measure of occupation offshoreability. It's international, so it's not what we want, which is within the US. So it's based on some coding that they did based on how easy it would be to offshore these occupations. They index occupations from 1 to 5. 1 is the least tradable. Then there was this paper by Goose, Solomon, and Manning in the AR providing evidence for this measure using firm-level data. And second, we use measures of industry tradability, like industries versus services, or manufacturing, mining, agriculture versus services. Again, it's not ideal because finance is very traded, so, but that's the best we can do.
So it's a tradable occupation?
Yeah.
Tradable occupation?
It's this. In the end, it's this. It's like these guys. I mean, they work in a location, but their output can be traded, clearly. Whereas
so
the output of
I see. Most of the people who are textile machines just so happen to work in industries that you would normally call that a tradable industry.
Right.
That's what you mean.
Right.
I see.
Right.
But then there's the
So secretaries would be completely confused.
That's right.
You
Well,
wouldn't
Kim
do
was
it
saying
that way.
accountants.
Right,
Some
I
work
see.
for,
Yeah.
the textile industry. Some work for the.
And the way you have the model set up, it doesn't cross over like that, like Kim was saying.
It's true. That's true. There's a final good that is not traded. Yeah. So that's why one check we did is we only look at services. We remove manufacturing. Okay. That takes away like 30% of the jobs, and we still have some. Some of these occupations that are employed not in manufacturing. That will be more consistent with the model.
Right.
Ideally, we want to have both manufacturing, both industries and occupations in the model, but then the data becomes very sparse. If you need like occupations and industry cells by region, by immigrants and natives, then we lose a lot. Yeah. All right, so now the baseline regression. So this is without distinguishing between T and N. The model says there should be a different beta for N and for T. Here we don't. So we do this, again, for low ed and for high education native workers. Again, you can see that the results are kind of similar if you do OLS or reduced form, at least the sign. On average, you get crowding out. Okay? So on average, there's a displacement. So native workers move away from immigrant-intensive occupations. Now we want to do it for T and N separately, which is what the model says we should do. So we run the same regression, but now there's an indicator and there's a different beta. Again, the model says that beta N should be negative. That's the only robust implication. Beta T could be positive or negative. What do we find? Beta T is 0, tightly estimated, yeah.
Yeah, just before you continue, so you said that you take into account, for example, education and country of origin. Do you also take into account, I mean, do you think that gender will play an important role?
We haven't done it with gender.
Because, I mean, I don't know, in certain occupations gender is kind of important. I mean, why don't
Yeah, we haven't tried that, but we could run this. I don't know if we have enough data, but probably we do. So we could do this by gender as well. We haven't, but okay. So the key implication is that, again, so this is 0 now, kind of tightly estimated. These are standard errors, pretty not that big, and beta N is negative. Okay, so which is the key implication of the model. How do we interpret this before doing the full structural thing, the full model in a few minutes? If you take, say, Los Angeles, so we're doing changes between 1980 and 2012. Take 2 occupations that are very differentially immigrant intensive. So private household services is very immigrant intensive. Firefighters are not. So the difference in the X The immigrant intensity is about 0.65. So if you multiply that by the coefficient, you're going to get 22%, which says that in response to an increase in the immigrants in Los Angeles in this period, employment by Americans in private household services fell 22% relative to employment of Americans in firefighters. That's what these coefficients mean. What do they imply for wages? Okay, what do they imply for wages? Basically, now we don't estimate that with the effect on wages. So we need a labor supply elasticity. We use 2. And if you divide 0.22 by 2, you get an 11% difference. So the wage of Americans that started in private household services fell, according to the model and these estimates, by 11% compared to firefighters. So there's changes in relative wages within regions. And these results are robust to a lot of to a bunch of things, but let me skip this.
What was it? Sorry, so by 11%. Did you put in the total number of people, so it's absolute, or are you doing all relative?
It's all relative. It's all comparing, it's over time, one occupation versus another. This is efficiency unit, per efficiency unit wages.
So can you do the actual, take like the actual people who went in and tell me an absolute number too?
You mean for the employment or for the wages?
For the wages.
Okay, so what we did is...
Are you going to do that later?
We're going to do that. Let me talk about that in a little bit, in the full model. Yes, we're going to have something on that. So one more thing we did before going to that, which is kind of going back to your question about the row difference. So here's another implication, something else we looked at in the data, which is we run exactly the same regression, but instead of using employment of, say, natives or immigrants, we use labor payments, to total wages. Okay? Why do we do that? Because in the model, labor payments are proportional to revenues. I mean, right? Because it's perfect competition or constant markups. There's no other factors. So labor payments, changes in labor payments are equal to changes in revenues. The model says that basically the quantity of tradable occupations that are immigrant intensive should increase by more than the quantity of non-tradable occupations that are non-traded, immigrant intensive. Right? That's the whole point of this epsilon being higher for T than for N. Okay? So that's what the model implies. And it implies the same for labor payments. Revenues for labor payments should increase relatively more in immigrant-intensive occupations that are tradable compared to immigrant-intensive occupations that are non-traded. Rho, if you match the previous fact with rho, you will get exactly the opposite on this. The model implies exactly the opposite. So this is kind of a good check of our mechanism, coming from the price sensitivity of demand. And when we run this regression in the data, we get exactly that. That on average, immigrant-intensive occupations expand. That's why this coefficient is positive. But they expand by less for non-traded immigrant-intensive occupations. So that's kind of one way of telling apart our mechanism from others. I mean, yeah.
If you write your full structural model, the wages and the prices, are tightly linked, right? So like, when it all hangs together, and you put in the wage change and the price change, and you have the wage change and the quantity change, the price change is then implied, right?
The total labor payments, adding up immigrants and native workers, has to be equal to P times Q. That is true. The price of an occupation? Yeah.
But there was this old stuff about trade, not immigrants, but trade.
Okay.
And people would run all these trade regressions. They just open it up to China, depress American wages.
Yes.
And Bagwadi would always say, we actually worked it out. The only way that wages can move in the trade model is the prices move. And the prices don't cooperate to get the story to work. And then people never simultaneously check the wages and the prices. There's an old criticism of the opening up the trade depresses wages. If you have a full equilibrium model, with all
Which we will have, yeah.
parameters at the end, the prices are
There's
they're completely pinned down.
There's two wages, right? There's immigrant wages and native workers. The combination of the two, the percentage change of the two, has to be equal to the change in the price. Yes.
Okay, now, but you in the data, if you have separate, you can check it almost.
Yeah, but the problem is that these are efficiency unit wages. Okay? So the ideal thing is to follow the same guy over time, assuming that his skill didn't change. So then we looked at.
But you don't have that kind of data, the tracking.
Let me tell you what I did in 1 minute. Okay. That's coming. So now we're going to do this in a quantitative model. So in the quantitative model, we do the following. So first, now workers are differentiated by their education level, consistent with the way we did the data. Second, this is not that important for the results within regions, but it's important for the results between regions. We're going to allow for agglomeration or congestion. There's going to be a little bit of agglomeration. So the more productivity on average goes up when the population goes up, but by very little. Just this is something that the literature thinks important, so we put it in. Third, we're going to allow in the model for workers to choose between locations, similar to the previous paper that we just saw, okay, like the way you did it. And fourth, the analytic results were done under, assuming the prices in the other regions were fixed. Now we're going to do the full general equilibrium. Okay, so for wages, what do we do? So in the data. So the model path says that this same regression should hold for occupation wages, but we don't observe this. Okay, so instead we could say, well, use average wages by occupation, rather than using, because that's a different, there's selection. It turns out in our model with Frechet, the average wage by occupation is the same. The average wage by occupation is the same across occupations. When we run this regression across occupations using these averages, we get that. There's neither, so the betas are basically zero. It's consistent with that. So that's not a way to test the implication for wages. But there's one implication we can test directly, which is using the average wages for, say, workers grouped by education. And it's like a weighted average of the changes in efficiency units weighted by the share of workers by education in each occupation. For this, selection cancels out the first order because the guy that switches is indifferent between where he was and where he's going. You see what I mean? So this one you can estimate in the data. What happens to wages by education? So when we run, I'm going to quick on this. We run a regression that lets us identify these parameters xi and xin using this. And in the model, we recover basically the true parameters. So in the model, this regression using wages by education works pretty well. When we do it in the data, the same regression, we get results that are qualitatively consistent. So this xi-n is negative. So that's consistent with the wages of workers in immigrant-intensive occupations falling more in N than in T. So that's the only thing we can do for wages. It's indirect, but it's using the model intensively, but it works. So finally, let me show you what the full model implies. So we're going to take this quantitative model. A lot of parameters, we're going to just take them from the literature, like trade elasticity, labor supply elasticity, mobility between workers, of workers between regions, agglomeration. Those are kind of from the literature. Trade costs, we're going to assume there's no trade for non-traded occupations. And for traded occupations, we're going to match regional trade shares in the United States. We have two parameters, the elasticity of distribution between native and immigrant workers and the elasticity of distribution between occupations. We're going to match the regressions that we run in the data, the same regression. Okay, so of course we cannot assume this equal to infinity because that would give us crowding out in traded occupations which we don't observe. So finally, we're gonna do some counterfactuals. What I have, like 5 minutes? 4?
Yeah, let's say 4.
Okay. So the first is now these are counterfactual exercises in the full model, in the extended model, calibrated to match the data that I showed you. So the first counterfactual is hopefully a counterfactual, just a counterfactual, maybe not, reducing the number of Latin American immigrants. So it's a national shock now. We cut the number of immigrants by 50%. Okay. So this is what happens in Los Angeles. Okay, in the model. So every dot is an occupation, the wage change by occupation. The blue dots are tradable. So you can see that on average, if you are in a very immigrant-intensive occupation or in a non-immigrant-intensive occupation, the wage is more or less the same. It doesn't matter if you start in furniture or in an occupation that is not very immigrant-intensive. Okay, so this line is pretty flat. Whereas for non-traded, it's very steep. So this is a reduction in immigrants. This says that gardeners are going to gain when immigrants leave Los Angeles compared to firefighters, which are here. And the difference is 8%. Okay, so there's a big implication for inequality within non-traded occupations, but not within traded occupations. Okay? So this is not specific to LA. If you do the max minus the mean weight change in each commuting zone, now each dot is one of the commuting zones, you see that the max minus mean, it can be up to 10% compared to tradables, which is about 0. So for tradables, it doesn't matter in what job you are. For non-tradables, it matters. So this is all about within region effects. What about between regions, which is more like the emphasis of the previous literature? So this is now average real wage across commuting zones. So on average, the real wage of native workers falls when you remove immigrants. Why does it fall? For two reasons. First, because you're removing a factor that is complementary. The elasticity is 6, it's not infinity. So when you remove a complementary factor, the marginal product falls. And second, because there's some agglomeration. So Miami, the real wage falls by 4% compared to some region that has very few Latin American immigrants, which the real wage doesn't change. But the point is that, and LA is around here, it's like 1%. The differences between regions are small compared to the differences within regions. That's the point I want to make. This is like the geographical variation. So these are regions where the real wage falls by a lot. Miami, that's the biggest one. There's a lot of regions that are not immigrant intensive. Okay? But the point is that within regions, the max minus mean, the difference is much larger. It's like 10% for Miami. Okay? And the last point is this difference.
You see the change in the composition and the counterfactual, the composition of output, the composition of occupations within regions?
More within T than within N. Very similar to the regression that we run with labor payments. So we're matching that pretty closely.
There's nothing crazy.
No, nothing crazy. And the final thing is, for the distinction between tradable and non-tradables, the type of shock you consider matters. If you feed in a uniform shock, a very similar shock across regions, then it doesn't matter if the good is tradable or non-tradable, because it's the same shock that is affecting everywhere. So to illustrate that, we double the number of college-educated immigrants. So it's a very different counterfactual. Okay, so now we're increasing the number of immigrants. We're not reducing it. One thing, this is the real wage change. So now the real wage goes up in all regions by more in San Jose, because it's very high skill intensive. But it's much more uniform across regions compared to the Latin American counterfactual. What that would imply is that, say within LA, the difference between the tradable changes in relative wages across occupations and non-tradable is much smaller. So the spatial distribution of the shocks really matters for the distinction between T and N. And for that, you need to use the model. So I'm going to finish here. So most of the literature exploited variation in exposure across regions, or say, comparing broad education groups. We're looking at variation in outcomes because workers are employed in occupations that vary in their immigrant intensity, and because of differences in tradability between occupations. Theoretically and empirically, we show that there's more crowding out across non-traded occupations compared to traded occupations. What that implies is that natives that are more exposed to immigration within non-tradables lose relatively more from immigration than those exposed within T. On average, immigration raises the real wage of native workers. In our model, that's very model specific. But the key is that there's large within region effects compared to between region effects. But the nature of the shock matters for this result. And that's it. Next.